Okay, for today, I'm going to show you a quick little video on how to find residuals and then show you an example of myself finding some easy residuals. So here we go. Here's the quick video.
Scatter plots, one of the concepts that we need to talk about are residuals. Okay, there's something called residuals that we want to talk about right now. And we just got a scatter plot right here. I'm not sure what the data means right now. That's not really important for knowing what a residual is. So eventually what ends up happening when you make a scatter plot is you probably want to come up with a line of best fit. And I'm just going to estimate my line of best fit to be somewhere right about here. Okay, the line of best fit gets pulled towards all of these points. Every single one of these points is pulling on this line of best fit. So some are being pulled down, these points below are pulling it down, these points are pulling it up. But anyways, once you find your line of best fit, there is something called residuals. And the little formula for residuals is this. You take your observed value minus your predicted value. Well, the observed values are basically the raw data that you have. Okay? You collected the data in some way. Those are the data points that you have observed. And then we use all of these observed values, all of these points in our scatter plot, to eventually come up with a line of best fit. And the points that are on this line of best fit, I'm going to change the color of it so that we can see it a little bit better. But the points that are on this line of best fit, those are the predicted values. Okay, these ones that are the predicted values are on the line. Okay, so how do we find a residual? Well, what we end up doing is we take just one of the points. Let's just say we took this point. It doesn't matter which one. Let's just take this point right here. Okay, if I take that point right there, and I take the observed value, okay, the observed value for your response variable, okay, that's what you're looking at, and you subtract away the predicted value, which comes from the line of best fit. So right here, the distance between these two smiley faces, these 2 points, the distance between the two would be considered the residual. Okay? If I take, I love it how I say okay, like I'm actually talking to somebody. You guys are, if you answer this video, then I don't know, does that mean there's something wrong with you? Probably not, but there we go. Let's take another point. Let's say this one right here is my this is my point, and I want to find the residual for this one. So this green point is my observed value. If I come straight down here to the line, and I take the value right here, the y value on this point, then the distance between these two y values is the residual. Okay? So residual is not that difficult. Now there's a couple other things that you should know about residuals. And you're going to get 2 types of residuals. You're either going to get a positive residual or you're going to get a negative residual. So what is true if we end up having a negative residual? Well, a negative residual means that the predicted value or your prediction is too high. Okay, let's talk through that there. If I go back up to my scatter plot and I take this point right here with the smiley faces, just as an estimate. This number down here, the y value for this particular point, this particular smiley face, let's say it was 10. And then the y value for its predicted value in the same spot that it goes with is 15. Well, 10 minus 15 is negative 5. So that should show you that if the residual is negative, right here I have a negative residual. If the residual is negative, then my predicted value is too high. I predicted that my y value would be right here, when in reality, according to this point, my y value was right here. Okay, so my predicted value is higher than my observed value, and that's what leads to this negative residual. So a negative residual, if you ever find one of those or have one of those, that means that the predicted value is too high. In contrast to that, if we have a positive residual, that means that the prediction is too low. So once again, a positive residual means that the prediction is too low. And we can see that with the green points here. If the y value right here is 8, and this one down here is 4, 8 minus 4 is positive 4, so I have a positive residual, which means that my prediction, remember the prediction is on the line, the prediction right here was too low. I have a positive residual, so the predicted value was lower than the actual observed value. And that's really, right now, all you need to know about residuals.
Okay, so keep on going. Here is my simple example for myself. So these are my predicted values. These are my observed values. To find my residuals, I'm going to take my observed values, looking at their values on the y-axis, and subtract their predicted values looking on the y-axis. I'm then going to have you calculate and average them and round your answers always to 2 decimal places. So here we go. This first one here, looking at value number 1, my observed value for 1, looking at the y-axis, is positive 1. My predicted value is 3. This is underneath the line, so this will give you a negative residual. Minusing 1, subtracting the predicted value 3, will give me a negative residual. So looking at this one, number 1, my observed value is 1. My predicted value is 3. 1 minus 3 obviously gives me a negative value, that is negative 2. Looking at this point number 2, this is above the line. It will have a positive residual. So my observed value for 2 is 6, looking at the y-axis. My predicted value is 4 1/4, or 4.25. So if I take that observed value of 6 minus the predicted value of 4.25, I get 1.75, and you can see again that is a positive residual above the line. Alright, number 3. The observed value is 8. The predicted value is 6. That is above the line, will give you a positive residual of 2.4. The observed value is 4. The predicted value is 5. Observed minus predicted gives me 4 minus 5 is negative 1. When I have you average these, don't take into consideration the negative. Use the absolute value of these, which are always the positive values. So when you're averaging, use all positive numbers. Don't add these negatives in there. So when I average them, I'm going to add all 4 values up. So I got 2, positive 2, make that absolute value, plus 1.75 plus 2 plus positive 1, again use absolute value, divided by 4 gives me 6.75, I believe, divided by 4, and that gives me a raw value of 1.6875, rounded to the second decimal place gives me 1.69. When you start to do more of these, you will see that when your average, your residual values, if your averages are small, the points are closer to that predicted line, you will have a higher correlation coefficient. If you average your residuals and you get a large number, that means your points are far away from that best fit line, that predicted value line. That means you will have a lower correlation coefficient. So again, the closer the residuals, the smaller the residuals, closer the points are to the line, the higher the correlation coefficient. The further away your residuals are, the lower the correlation coefficient. All right, good luck.